Why is early return slower than else? This is a follow-up question to an answer I gave a few days back. Edit: it seems that the op of that question already used the code I posted to him to ask the same question, but I was unaware of it. Apologies. The answers provided are different though. Substantially, I observed that. Or in other words, having the else clause is faster regardless of the if condition being triggered or not. I assume it has to do with different bytecode generated by the two, but is anybody able to confirm/explain in detail? Edit: seems not everybody is able to reproduce my timings, so I thought it might be useful to give some info on my system. I'm running Ubuntu 11.10 64-bit with the default Python installed. Python generates the following version information. Here are the results of the disassembly in Python 2.7.
This is a pure guess, and I haven't figured out an easy way to check whether it is right, but I have a theory for you. I tried your code and get the same of results. Without underscore else is repeatedly slightly slower than with underscore else. Considering that the bytecode is identical, the only difference is the name of the function. In particular, the timing test does a lookup on the global name. Try renaming without underscore else and the difference disappears. My guess is that without underscore else has a hash collision with something else in globals, so the global name lookup is slightly slower. Edit: a dictionary with 7 or 8 keys probably has 32 slots, so on that basis without underscore else has a hash collision with underscore built-ins underscore. To clarify how the hashing works, underscore built-ins underscore hashes to -1,196,389,688, which reduced modulo the table size, 32, means it is stored in the number 8 slot of the table. Without underscore else hashes to 505,688,136, which reduced modulo 32 is 8, so there's a collision. To resolve this, Python calculates. Starting with. Repeat this until we find a free slot, which gives it 17 to use as the next index. Fortunately, that's free, so the loop only repeats once. The hash table size is a power of 2, so 2i is the size of the hash table, I is the number of bits used from the hash value j. Each probe into the table can find one of these. The slot is empty. In that case the probing stops and we know the value is not in the table. The slot is unused but was used in the past, in which case we go try the next value calculated as above. The slot is full but the full hash value stored in the table isn't the same as the hash of the key we are looking for. That's what happens in the case of underscore built-ins underscore versus without underscore else. The slot is full and has exactly the hash value we want, Then Python checks to see if the key and the object we are looking up are the same object, which in this case they will be because short strings that could be identifiers are in turn so identical identifiers use the exact same string. Finally, when the slot is full, the hash matches exactly, but the keys are not the identical object, then and only then will Python try comparing them for equality. This is comparatively slow, but in the case of name lookups shouldn't actually happen.
If you want to see more, please consider subscribing.